In today's video, I want to go over some formulas that's associated with forces if you're studying that chapter in physics. So let's begin. The first formula you need to be familiar with is the formula associated with Newton's second law. That is, the net force is the product of the mass times the acceleration. Now, this of course could be in the x direction or in the y direction. Now, another thing you need to be able to do is you need to be able to draw a free body diagram. A free body diagram shows all of the forces that are acting on an object. So let's say we have a box that rests on a horizontal surface, and we want to draw all the forces that are acting on it. So let's say we have an applied force that pushes the box to the right. If there's friction between the surface and the box, the frictional force will oppose the direction of motion. So if you try to push the box to the right, friction is going to be applied to the left. Now, if the box is not moving, you're going to have what is known as static friction. Static friction, represented by F sub S, it's an inequality. It's less than or equal to the coefficient of static friction times the normal force. Now, if the box is sliding to the right, then this friction is no longer static friction, but kinetic friction. Kinetic friction is equal to mu k times the normal force. The kinetic friction has a specific constant value based on these two things. The static frictional force is basically a range. The static frictional force will be equal to the applied force up to a limit. Once that limit has been exceeded, the box will begin to slide and kinetic friction will now be active. So static friction is only present as you try to move the box, but when it's not moving. But once it begins to move, then you have kinetic friction. So these are the formulas you need to know for static friction and kinetic friction. Now you might be wondering, what is the normal force? The normal force is basically the force that is exerted from the ground on the box. Keep in mind, the box exerts a weight force. That weight force is equal to W, which is mg, the mass of the box times the gravitational acceleration. The gravitational acceleration is 9.8. meters per second squared. Now, we talked about the net force being equal to ma. This is the basic idea behind Newton's second law of motion. Now, you need to be familiar with the formula of Newton's third law of motion, which is basically for every action force, there is an equal and opposite reaction force. So you could think of the weight force as an action force due to gravity. Well, the ground is going to exert a reaction force that is equal and opposite to the weight force for this particular specific diagram. So the normal force is going to be the reaction force to gravity. And in this example, it's equal to the weight force. So by the way, this formula can change based on the specific type of shape you're dealing with. So for this particular type of shape, when you have a box or an object on a horizontal surface, the normal force is equal to the weight force. But that formula can change based on a variety of factors. Now, let's say if we want to determine the sum of the forces in the x direction, which is basically the net force in the x direction. This one is going towards the right, towards the positive x-axis, so we're going to give it a positive value. This one is going towards the left, so we're going to give it a negative value. So the sum of the forces in the x direction is simply the difference between these two. And you could set this equal to ma. A will be the acceleration in the x direction. Based on Newton's second law, the net force is equal to ma. Now, if we want to find the net force, or the sum of the forces in the y direction, it's going to be the difference between these two. So it's going to be the normal force minus the weight force. Now, for this particular example, the box is neither accelerating upward or downward, it's simply at rest, so the net force in the y direction will be 0. Therefore, these two will equal each other, and we can see that the normal force will be mg. Now, if the box was accelerating upward, then this would be different. But we don't have that for this particular case. Now, let's consider another situation. So let's say we have a box, and we're applying a force on this box just like before. Actually, this time we're not going to push the box to the right. We are going to pull it to the right with a tension force. A tension force is basically the force that acts through a rope. Now, because this tension force is at an angle, it's going to have an x component, tx, and a y component, ty. And here we have the angle theta. Now, if we're pulling the box to the right, and if it's moving, friction, assuming there's friction between the box and the surface, is going to be in the opposite direction. Friction always points opposite to the direction of motion, so it's going to be to the left. We're going to have the weight force, mg, and we're also going to have a normal force, Fn. Tx is equal to t cosine theta. Ty is t sine theta. If you need to calculate t, it's basically the hypotenuse of the right triangle. So it's going to be the square root of tx squared plus ty squared. And if you need to calculate the angle, you could use this formula, arctangent ty over tx. But using SOHCAHTOA, you can also use sine and cosine. So the angle theta will be the arc cosine of tx over t, adjacent over hypotenuse. Theta can also be arc sine ty over t, opposite over hypotenuse. So if you saw my trig videos, it'll explain how you can find sine, cosine, and tangent using the right triangle. Now, how can we determine the normal force for this particular situation? Because it's not going to be mg like it was last time. So first, let's determine the sum of the forces in the x direction and in the y direction. The sum of the forces in the x direction, tx is in the x direction. It's going towards the positive x-axis, so it's going to be positive. Fk is going towards the negative x-axis, so it's going to be negative. So that's the sum of the forces in the x direction. Now, if the box is accelerating towards the right, f of x doesn't equal 0. Instead, we could set it equal to ma. So if you need to calculate the acceleration in the x direction, you could use these formulas. You know how to calculate tx, it's t cosine theta, and you know how to calculate fk, which is mu k times the normal force. But you need a different formula for the normal force in this case. So let's look at the forces in the y direction. In the y direction, we have these three forces. So the normal force is going up. That means it's going to be positive Fn. Ty is going up, so it's positive Ty. The weight force, mg, is going down, so it's negative mg. Now, we need to determine if we should set this equal to 0 or ma in the y direction. This box is neither accelerating upward or downward. It's simply moving to the right. So therefore, in terms of the y direction, it's at rest. Not in the x direction, but in the y direction. It's not being lifted above the ground, and it's not falling below the ground. So therefore, we could set the sum of the forces in the y direction to be 0, which means that these two forces, they balance out the weight force. So what we need to do is we need to solve for Fn. So we have Fn plus Ty minus mg is equal to 0. So if we move this to the right side, it's going to be positive mg, And if we move Ty to the right side, it will be negative Ty. So we get that the normal force is the weight force minus Ty. And if you think about it conceptually, the normal force has to support the weight force, but it's being assisted by the y component of the tension force. So therefore, the ground doesn't have to exert as much force as it needs to support the entire weight, because the y component of the tension force supports some of the weight of the object, which means the normal force will be less than what it normally would be, like it was in the last example. So in this example, it's the difference between the weight force and Ty. So that's how you can calculate the normal force in this example. Now we know what Ty is. Ty is T sine theta. So you can also save this equation. By the way, you could find these equations, or at least most of them, in the formula sheet that I've created, which I'm going to post down in the description section below. So for any of you who want to get a printout of these formulas, feel free to take a look at that. Now, the formula sheet is going to have way more formulas than you see in this video, because there's a lot to cover. And so I'm just going to post it in the formula sheet for those of you who want additional formulas beyond what you see in this video. Now, let's say if you have a horizontal surface and you have two boxes. The mass of the first box is m1, the mass of the second box m2. And we are going to apply a force to push these boxes to the right. And let's say that there's no friction between the boxes and the horizontal surface. Now in this problem, we want to calculate the contact force, the force that m1 exerts on m2. Now this is equal to the force that m2 exerts on m1. Based on Newton's third law, for every action force, there is an equal but opposite reaction force. So the force that box 1 exerts on box 2 is going to be equal in magnitude, but opposite in direction to the force that box 2 exerts on box 1. So just keep that in mind. But how do we calculate this contact force? Here's a simple formula that will explain how to do it. So this force here, it's responsible for pushing box 2 to the right. So that force is going to be the mass of box 2 divided by the total mass times the applied force. So this force is basically a ratio of, it's based on the ratio of this mass relative to the total mass, but times this force. So it's proportional to this force. The total mass, mt, in this problem is m1 plus m2. So that's a simple formula that you could use to calculate the contact force between the two boxes. If you need to calculate the acceleration of the system, keep in mind the net force is ma based on Newton's second law. So to calculate A, it's going to be the net force divided by m. But that net force is basically the applied force, because that's the only main force that's really pushing the entire system to the right. So if you take that applied force and divide it by the total mass of the system, mt, it will give you the acceleration of both boxes. Because they move together, the acceleration will be the same. So that's how you could find the acceleration of the two boxes, is by taking the applied force and divided by the total mass of the system. Now, what if we have a situation with three boxes? Let's say this is m1, m2, and m3. And we're going to have an applied force. For this example, we're not going to consider friction. Now, this is going to be the force that box 1 exerts on box 2, and this is going to be the force that box 2 exerts on box 3. Just like before, the acceleration of all three boxes is going to be the total force, which is this particular force here, the force that is responsible for moving the entire system to the right, and it's going to be divided by the total mass. The total mass is the sum of the three masses. Now the force that box 1 exerts on box 2, that force is responsible for pushing both box 2 and 3 to the right. So it's going to be m2 plus m3 divided by the total mass, but multiplied by the applied force to the left. Similarly, the force that box 2 exerts on box 3, that force only pushes box 3 to the right. So it's going to be the mass of box 3 divided by the total mass times the applied force F. So that's how you can easily calculate those contact forces. Now let's talk about tension force. So let's say we have a tension force, I'm going to call it Ft, that pulls box 1 and 2 to the right. And we want to calculate the tension force in the middle that pulls box 1 to the right. The acceleration of the system is going to be the applied force, which is this tension force pulling the whole system to the right, divided by the total mass. Very similar to the last two situations. And we know for this example, the total mass is just m1 plus m2. Now, if we want to calculate T in this example, T is only responsible for pulling just m1 to the right. So it's going to be the mass of object 1 divided by the total mass times the applied force, which is basically the tension force to the right. So that's how we can easily calculate this tension force here. Now, let's consider the situation when we have three boxes. So let's call this M1, M2, and M3. T1, that's the tension that's going to pull block 1 to the right, and T2 is the tension that will pull block 2 to the right. We want to be able to calculate T1 and T2 from Ft. So just like before, the acceleration of the entire system is going to be the net force driving the system to the right, which is Ft. That's Ft is the force that creates these other forces. So you could think of it as the net force of this entire system. So net force divided by total mass will give us the acceleration. And the total mass of the system is m1 plus m2 plus m3. Now, T1 is only responsible for pulling m1 to the right. So T1 is going to be m1 divided by the total mass, which is the sum of those three masses, times Ft, or you can call it just F if you want. Now, T2 doesn't just pull block 2, it also pulls block 1 to the right. So T2 is responsible for pulling these two blocks to the right. So it turns out that T2 is m1 plus m2 divided by the total mass times F. So I'm going to stop the video here because there's a lot of other formulas to consider, which I'm going to put that in the formula sheet, and you'll find these formulas in the formula sheet as well. Also, for those of you who want to see example problems on these particular topics, as well as how to derive some of these formulas, feel free to check out the links in the description section below. I'm going to post some videos where you can see some example problems on how to use these formulas, in addition to other example problems. By the way, the formula sheet will have formulas that deal with pulleys, inclined planes, and combinations of pulleys and inclined planes. So if you want the formulas on how to calculate acceleration and the tension force for those situations, feel free to check out that formula sheet down below. So that's it for this video. I'm going to stop it here, and thanks again for watching.